Okay, so 6-4 is on multiplicative inverses of matrices and matrix equations. So inverses of matrices are going to be how we divide matrices, because you can't actually divide matrices. So first of all, just understanding that multiplicative inverse is of a number is its reciprocal, because when you multiply something like 8 and 1/8 together, you get 1. The multiplicative inverse of a matrix is its inverse matrix. Usually it does involve a bunch of like weird little fractions, but that's not really the point. Alright, so we, this little sentence right here, I thought was kind of funny. This one. But if you don't do 1 divided by a, because you can't divide matrix, but also like 1/8 is the same thing as 8 to the negative 1. So it's really not even like we're doing anything different. Okay. Anyway. Alright, when you multiply a number by its reciprocal, you get 1. When you multiply a matrix by its inverse matrix, then you get the identity matrix, which is basically a 1, because the identity matrix is going to look like this. If you have a 2x2 identity matrix, then it's a 1 here, and zeros. If I wanted to get fancy and tell you to do a 5x5, then you would just have 1s along the diagonal and fill in with zeros the rest of the way to make a 5x5. Okay, so identity matrix has 1s along the diagonal, and everything else is zeros. That's the identity matrix. So if you multiply a matrix times its inverse, you should get the identity matrix, which works as just 1, which is going to help us when we're solving these matrix equations in a minute. Okay, so the definition of an inverse is that when you multiply a matrix and its inverse, you get the identity. Okay, if we're going to find the inverse of a matrix, you can do that by hand for a 2x2. Anything bigger than that, it's super complicated, and you just use your calculator. Okay, so for 2x2, we will do by hand, and it's this little formula. If you're given this matrix, to find its inverse, you're first of all going to rearrange the pieces. So this diagonal switches, this diagonal changes signs. And then you multiply these minus multiply these to get this denominator for that multiplier on the outside. This is called the determinant, but we'll talk about that in the next lesson. So for now, you just need to understand that if I give you this 2x2, you have to do this to get its inverse. So out of everything on this slide, if I were going to write something down, it would be this formula. And it doesn't matter if that's the determinant right now. And the fact that this is a true statement. Okay. So let's practice, can we find an identity? Okay, again, for a 2x2, for the inverse. Can we find an inverse? And for a 2x2, we can do that by hand. So first of all, we're going to switch these, change the sign of these. And then we're going to multiply by 1 over, multiply these minus multiply those. I cannot write. That was supposed to be a parenthesis and a 7. Alright, so this is 24 minus 14, so 10. So that's 1/10 that we're going to multiply through this matrix to give us 6/10. I'm going to go ahead and just do decimals. Negative 7/10, negative 2/10, and 4/10. Alright, on your homework, it's going to tell you to find the inverse and then multiply to verify that they are inverses, that you get the identity. I don't want you to do that. There are 2 problems where they give you 2 and ask you if they're inverses, so you're going to have to multiply the 2 matrices in both directions and show that you get the identity matrix. Only on those first 2 do you actually have to do that verifying piece. On the rest of them, will ask you to find an inverse. You can ignore the directions about verifying. Alright, so Number 2, let's see if we can do this one by hand. Alright, so we're going to switch this diagonal, change the sign of this diagonal. And then we're going to do 1 over 2 times negative 2 plus 1 times negative 6, which is negative 4 plus negative 6, so is that negative 10? I just randomly picked problems and ended up with ones with the same little multiplier, basically. Alright, so again, you can call that 2/10 or 1/5, or you can call it 0.2. I don't care which of those you give me. That's not negative, is it? It is 2 negatives. That clearly makes positive. Alright, I believe that is correct. Alright, for a 2 by 2, I'd like for you to do those by hand. For a 3 by 3, we're going to use the calculator. Anything bigger than a 2 by 2, you're going to use a calculator. If I didn't say this earlier, you can only do an inverse of a square matrix. So the formula for a 2 by 2, anything else, you're going to use your calculator. So let's see if we can do that. Okay, so you are doing matrices, so we want to make sure that you can see the problem. We want to make sure that we are in the matrix. So go second matrix, matrix new, over to edit, so that we can type in something for matrix A. Alright, matrix A is a 3 by 3. And it has the numbers 2, 2, negative 1, 0, 3, negative 1, negative 1, negative 2, 1. I didn't say this in a previous lesson, but I always like go back and double check and make sure, because if you miss a negative, then everything is wrong, and you get super frustrated. Okay, those all look right. Alright, so second quit to get out of there, because otherwise it just tries to enter it into your matrix. Alright, so we go back to matrix and tell it we want matrix A. And then we just need the little inverse symbol in our calculator. So remember we said that we're literally trying to find, it's not going to be right, because I'm not on pen. We're trying to find A inverse. So we need it to say that in the calculator. So if you look at that button that we've been pushing for matrix, you see how it says x to the negative 1? So we've been pushing this button for matrix. It says x to the negative 1. Well, if you'll click that button, it puts the little negative 1. So this is telling the calculator I want the inverse of A. Hit enter, and it will give you the inverse of A. This one has a pretty inverse. They don't always have pretty inverses. So let me, first of all, let's write this down as an answer, and then I want you to see, because it's probably going to happen on your assignment, and I don't want you to be confused. If I change one little number about this matrix, then it's probably going to completely mess things up. So let me see if I can do that. Let's make that a 5. Alright, so now when I try to find it, really? It doesn't give me enough questions. Alright, so instead of wasting your time, we're just going to call this a 2 by 2. And go back and put in this guy that we know ended up with decimal. So this 4726. Alright, so you see how it gives you decimals? Sometimes it's going to give you really, really gross decimals. So remember that if I want decimals to become fractions, I can just do math, like the button that says math right here. And then say that I want fraction, and then hit enter, and it will turn it into fractions. So if you have simple decimals like this, you can leave them. But if this said 0.6235 dot 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 dot, then it's better to do the fraction button and give me fractions. Alright, I believe, is that all we have for today? No, because we're doing matrix equations. Duh. Okay, so for a matrix equation, you are going to basically solve this. So we would like to divide by A. Remember, we can't divide by A. But multiplying by something's multiplicative inverse is the same thing as dividing. So if we had 2x is equal to 8, we would just divide by 2. But that's the same thing as saying times 1/2. So that's what we're going to do here. We, instead of dividing by A, we multiply by the inverse on both sides. These cancel out, and I'm left with A inverse times B on the other side. Now remember, matrix multiplication is not commutative, so that order is important. We have to do A inverse times B. As long as we understand this simple concept and can use our calculator, solving a system of equations is pretty simple using a matrix equation. All right, so the first thing is, can we write it as a matrix equation? All right, so we're going to turn a system into a matrix equation. You want a matrix of your coefficients. So 7, 5, 3, 2. If anything was negative, it would just go in here as negative. Like if that was -5, this would be a -5. Then you need a matrix of your variables. So x, y. X, y, so x, y in a column. Equal to a matrix of your constants. Alright, so coefficient matrix, variable matrix equals a constant matrix. Alright, so to show work for this, we're going to say this is A, and this is B, and this is our variable x. So to get x, we're going to do the inverse of A times B. So we end up with, we know that this is equal to whatever comes out of our calculator, which will give us an x and a y. Alright, so let's look at the calculator. Let's first of all make sure we can see the color. Okay, so in your calculator, go to matrix, over to edit, choose matrix A. It's a 2 by 2 with the elements 7, 5, 3, and 2. Second click, back to matrix, over to edit. Now choose matrix B. It's a 2 by 1 with the numbers 23 and 10. So now if you tell it to do matrix A inverse, and then times matrix B, then it tells you that we get 4, -1. So from that first lesson, we know that if these two matrices are equal, then x has to be 4 and y has to be -1. So we solved the system. We figured out that that's the ordered pair where they cross. All right, so for the next one, your variable matrix is going to be 1, 4, -1, 1, 3, -2, 2, 7, -5. This one has variables x, y, z. It's important that if they do not give you all of your equations in standard form, that you put them in standard form, meaning that the variables are in alphabetical order and all on the same side. All right, and then we're equal to the constant matrix, or the answer matrix. All right, so again, call this guy A, this one X, this one B. And we have a matrix equation, so to get x, we're going to do the inverse of A times B. So we will go to our calculator, come up with a matrix, and we will know what x, y, and z are. So for a 2 by 2 system, matrix equations are not necessarily faster, because a lot of times you can do those pretty quick. But for a 3 by 3 system, I would say matrix equations are a lot faster. All right, so let's see. We have matrix A is a 3 by 3 with the numbers 1, 4, negative 1, 1, 3, negative 2, 2, 7, negative 5. Double check 1, 4, negative 1, 1, 3, negative 2, 2, 7, negative 5. All right. Then we have matrix B is a 3 by 1. And those numbers are 3, 5, and 12. Alright, so then we want inverse of A times B, and I just did second in there because that's the last thing that I typed in the calculator. And it tells me 1, 0, negative 2. So, I hate that this jumps back and forth when I make it small and big. 1, 0, negative 2, meaning that the answer to the system is this ordered pair. Alright. I believe that we are done. Yes. Alright, make sure you pay attention. I don't want you to do 12 and 18 by hand. That's just finding the inverse of a 2 by 2. Remember that you do not have to, I guess I should say 13 and 18, huh? Remember that you do not have to do the verifying parts on 13, 18, 20, and 25. I think those are the right numbers. Alright, if you have questions, please let me know.